Hey everybody, this is Larry. This is me going over Q4 of the biweekly Kindness 165 maximum XOR of subsequences. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this one. Let me first start by saying that this problem is not a good problem for interview. So I would say, unless you really are trying to level up in competitive programming or something, I would not worry about it. It's fine. It requires techniques that are just silly, right? If you ask me. So I'm having a little bit of allergy issue, so I need to kind of pause every couple of seconds. And I'm just trying to bring up the drawing board, but apparently I clicked on the wrong thing. Hey everybody. Yeah, just cutting in for a quick moment. My first attempt in doing this intro, I kind of messed up a little bit in the explanation in that I assumed people already knew some stuff, some observation about this problem. So I'm jumping in right here to kind of just point out a few things that I just forgot to mention because I took it for granted. The first thing to note is that even though you have two subsequence, you only need one of them, right? Because you're going to XOR them. And if you XOR the X and the Y, and you could just basically already pre-XOR it, if you will, right? You just put it on the one subsequence. So basically only finding the XOR of one subsequence. So that makes it a lot easier, or just simplify things a little bit. Just want to put it out there for a quick minute. Anyway, back to Larry. But okay. Yeah, and the idea behind this problem is just this thing called XOR basis. I'm not gonna lie. Full disclosure is that this is not my strong area. I knew about this from a while ago, but I've never learned it properly, and I still haven't because I believe this is bull for Leetcode and interviewing in general. Maybe I'm forced to a little bit, but I don't know. So if my explanation is not great, my apologies. I'm just going to give you my intuition of how I led to my solution. And some part of it is a little bit of a black box, but I just want to get you to, just my thought process. Like I said, it may not be even good, but we'll see how that goes. But the idea behind XOR basis is, for me, is just the same basis in linear algebra, right? And what I mean by that is that, the idea here is that the idea behind basis, and there is a lot of linear algebra background. I'm trying to think through what is the best way to go about it, and I have the linear algebra background. And I still struggle, so it's hard to say, right? But no. But this part of the linear algebra maybe is pretty okay. And there are different ways to write this one, but because you can also do reduced row echelon form in theory, but because n is so big, you have to do like this special idea to get the basis, right? Taking advantage of the fact that there are only 32 bits, right? Or I guess technically, more strictly speaking, 30, but I always say 32 for the number unsigned bits, just out of, I don't know, whatever, right? Fixed with things. But the idea here is that, okay, in linear algebra, you have this idea of like, okay, well, first, it's tough because there's a lot of linear algebra, basic stuff perhaps, but still quite a bit if you haven't done it before. But the idea here, and hopefully when I said reducible echelon form, it gives you an idea. But one thing that reducible echelon form gives you is this idea of independent dimensions or vectors. Or I guess technically the vectors are independent. Dimensions are always by definition independent. Or the basis for the dimensions, if you want to call it that, because dimension is not a vector. I'm being very like. My apologies if you have a math background. My language is a little bit lazy for sure. I'm trying to correct myself. I know it, but I'm a little bit lazy on the vocabulary, and my apologies. But the idea here is that, okay, so we look at each bit by itself. right? Because in a way, XOR is linearly it's a linear combination of each other, right? The way that every bit is linearly independent from each other. It's something that we talk about a lot for different XOR problems. Still true here, but what's more precise is that it allows you to do a set of linear equations, right? Because the idea that we usually go with XOR is that if you have some number and let's say this is a number, so it goes up and down, right? The idea here is that if you have some idea, some greedy thing, we can always take one bit at a time, because anything that we do with this bit cannot affect, say, this bit, right? In terms of like an example that where it can affect is if you do a regular addition. If you do regular addition, well, this will get carried over to the 1, so that's no bueno. But in this case with XOR, no matter what you do, everything is within itself, right? So that's where the linear independence comes into play anyway. Okay. And then the idea for this one is just that, well, now we're trying to do reducible echelon form, and it's a little bit confusing because now I'm transposing what I want to do with respect to the numbers, right? Because now we have like, and the reason why this idea of basis and reducible echelon and dimensional works is because in a greedy kind of way, it is the same idea about greedy that we've done before with other XOR problems, right? Hopefully. Anyway, if not, then there are a lot of XOR problems you gotta go back and practice. What I mean by that is that we're just optimizing one bit at a time, right? And so what does dimension mean, right? Let's jump to that next. In linear algebra, the number of dimension means just the number of things that are independent from each other, right? Meaning that maybe in the opposite direction, if there's no dimension that leads with a given index, like, then in that case, that means that in the opposite world, or I guess inverse, is it? In the inverse case, if there's no dimension with a particular bit, it means that that bit is wholly dependent on other bits, right? And that means that bit, there's no choice, because whether that bit is a 0 or a 1 depends on another bit. And of course, there are a couple of ways you can interpret that, right? But the way that is more relevant to this problem is that if a bit depends on another bit, well, in a greedy way, we want the least significant bits to depend on the more significant bits, right? Because in a greedy way, the most significant bits, we want to be able to choose that, and then the rest almost, quote, doesn't matter, right? It doesn't matter in the sense that it doesn't matter in the sense that it doesn't matter in the sense that in a greedy kind of way, right? Like, and what I mean by that is that it doesn't matter. Like, we'll do a digital or a base 10 example. Is that if you have if we optimize for the first bit, even if even if the rest of the bit doesn't matter, because if the first bit is 0, this number will always be bigger than this number. So, in base 10, we have the intuition. So it's the same thing here, because it doesn't matter, like, not that it doesn't matter, it matters in terms of the answer, but we have no choice here, right? Like, it doesn't, like, what this bit is uniquely determined by this bit, then it doesn't matter whether this is a 0 or 1, because we have no choice. That's what linearly dependent means. And so, as a result, for this problem, we're trying to figure out what we call the basis. The basis is just a set of vectors that I'm trying to be precise, and also maybe like the position doesn't matter in the sense of like it's very precise. But the idea then now is that we're trying to figure out, okay, So in this example, we might say that this bit, and then and then maybe this bit depends on this bit depends on this bit, dot dot dot, right? And then now the basis is just a set of numbers that gives you that are linearly independent from each other, meaning that you do have a choice to whether choose them or not, to add to the result, right? And because you have a choice, you could choose whether that is 0 or 1. And that's basically the idea behind this problem, is that if once you're able to get the basis, then now you just have to construct the max answer from that basis, because everything else is no choice, right? Everything else is every bit depending on each bit. But just also to be clear, one bit could be because this thing, let's say that it means that this bit depends on the previous bit. It means that this bit is not linearly independent, but also it's not a one-to-one thing, right? It could also be like this bit depends on this bit, the same way, and so because this bit is independent from this bit, that's right next, right? So that means that so we still have no choice here, but we have a choice here and an earlier thing, and whatever these two we choose, this one is determined by the choices that we made. And that's kind of the answer. I know that this is very hand-wavy. I'm not going over look, there is a lot of linear algebra background for this. I mean, nothing too hard, intro linear algebra, but it's still, there's a class for this the entire semester, right? So there's a lot of stuff that I'm probably not going into super detail, but hopefully that gives you a taste, especially if you have a little bit of a linear algebra background, right? The algorithmic part about this is that there is, I actually made a wrong answer. I forget how. Oh yeah, I just kind of rushed through it and I didn't go through it. But yeah, so the algorithmic part of this, and the sorting is actually not necessary, but it doesn't really matter. The algorithmic part about this is this part, is that usually when you do reducible echelon form, it's going to be n squared, right? In this case, you can actually do it. Well, I mean, I guess maybe not. It depends how you define things. But in any case, this is the quicker way to do it, which is going to take O of n times b times, where b is the number of bits, right? And this is pretty straightforward to think about, maybe, hopefully, which is that for each bit, we go, for each number, we look at it one by one, and we go, okay, well, if this x has this bit, that means that it has control over this particular bit, right? That means that if x in this number has a 1 in that location, that means that it can control it, because you could flip it from 0 to 1 and 1 to 0. That means that it can be uniquely represented. And maybe I should really do it. If bits of I is none, then we set it as the basis for that index I, right? Meaning that now this current number x can uniquely change the outcome for this particular index. Otherwise, we do an XOR. Why do we do an XOR? Because then now, in a way, we're subtracting out this bit, right? And keep in mind that the ordering matters. This I is going from most significant bit to the least significant bit. So when you XOR this out, actually this is kind of doing the reducible echelon form, right? It's basically looking at all the previous bases, and we can only have 32 of them, as we said. Maybe 30 if you want to be more strict speaking, but 32 of them, right? And there are only 32 of these, and they're all the bases. And what this does is, in a prefix kind of way, we move every prefix, right? Because now, let's say you have a number that's a binary number that looks like this. Well, and if previous number is already defined, then whatever this is, it will always get rid of this 0. Maybe gets it rid of more bits, but it will always at least get rid of the first bit and then now it goes to the next bit and then does the same, right? Like maybe it flips this, but then now right? So then when this is done, either it just ends at 0 and you're just like, well, it's 0, so we're done. Because if it's 0, it means that every bit that is in this number can be determined by other numbers, right? That's it. And if it's not, let's say there's this left, that means that this bit, that means that we have control over this particular bit, and then we just set it, which is what we do here. That's it. That's the XOR basis algorithm in a nutshell. Man, I don't know why I'm struggling with breathing today, but it is what it is. But yeah, so that's that, right? And then getting the max part. This part, actually, I wrote it a little bit weird, but I could actually rewrite this in a different way. I mean, this is now that I kind of explained it the way that I did before I showed the code, doesn't make sense as much. I mean, it does, but yeah. But what I want to write is that and I think this is right. If not, then I'll be very sad. I mean, by definition, it should be right. Yeah. I don't know how these things get, like, it just pops up in random windows. Leetcode, I swear. But yeah, but the idea here is that as we establish, right, now we're going to do greedy one bit at a time. And because we're doing one bit at a time, we're going to start with the most significant bit, right? And then that means that if we have control over this bit, if it's not none, then we have control over this bit. And if the current thing at this bit is a 0, that means that we want to flip into a 1 in a greedy kind of way. And we want to go from 0 to 1, then we just flip it. And once we flip it, we flip it. And we have to, of course, also flip the rest of it that is depending on this one. And then that's basically the idea. And that's it. Yeah. This is O of N B. That's why a lot of people got it. Is that if you ask me, is because there was like another contest maybe 2 months ago that had a harder version of this problem, which I refused to learn, like I said. But I mean, I don't know. I figured it out from first principles and some memory of that problem. But honestly, like I said, not an interview problem, so I wouldn't worry that much about it. But yeah, this is n times b, and this is n times b. Like I said, I refuse to learn it, so at least on a deeper level. So that's it. That's all I have for this one for now. Thanks for watching, and yeah, let me know in the comments what you think, and you could watch me solve a live done contest now. Really annoying problem, but I really thought that. Yeah, I mean, I thought 4 was possible. I guess that's cost me a couple of wrong answers. But all right, we have 47 minutes left. Whew, a lot of silly mistakes there, but hopefully we should be able to finish. A lot of people finish early, but I mean, those are cheaters, so I guess whatever. But all right, integer array nums where each element is a non-negative integer. All right, let me read it. Okay, you're given nums, okay. Select 2 subsequences in which x is the bitwise XOR of all the bits in the first subsequence. Okay. Ooh. Maximum, okay, so you want x XOR y. Have to be non-empty. What does overlap mean? I guess the overlap doesn't really matter because that means that it just becomes 0. So I mean, yeah, the overlap doesn't really matter. Though, oh, can it be empty? It's very weird. It's just. There's no 2 sequences there. I think the sequences are a lie. They may be empty, so one of them would always be empty because it doesn't. Because you would just put it in the second sequence. So you have one sequence, right? But I forget how to do it. I feel like this is pretty standard though. Maybe I'll think of something else. But so maximum subsequence XOR. Right. In this case, you just take 3. You don't even do the other one. I mean, yeah, you could. You sort by bits. Okay, let's say we do greedy bit by bit, right? Do you always take 1 or? What would that look like? What would that look like? So it's at least the biggest number, and then you work on if you could improve on it. And you could improve on it if there's always pairs of numbers, isn't there? So we take the biggest number, okay, and then we see if it could be a combination of stuff, right? Because for example, you could have like oops, I mean 2,000 people solved it, so it should be doable. But that, I mean, that only has up to 30 bits, but 30 bits is interesting. That means that at most it's going to be 30 numbers, right? Is that true? Maybe that's not true actually. Is this actually the worst case? You don't, okay, so the number of numbers don't matter. It's just whether you could get a number. So, okay. Question is, can you be greedy and then not, right? No, I don't think so. because of the pigeonhole principle. Because if you added this bit, no, it could be a combination of stuff that adds together. So maybe it's very incremental changes, but it could, you have a lot of numbers inside it. Excuse me. And you can't just take one number at a time. Because you may be able to add numbers and then later come back to get that bit. For example, if this is like a 1, and then oops, and then you have like a lot of I don't know. Or maybe even just something like this. And then like the prefix matters, but in a weird way. Like if you like you have this, you may never do this one or this one, but then together they combine to be which is maybe what you would want later, and then but as a result, I don't know. Why am I so bad these days? It is still at least the max number. I don't think there's like a try greedy solution unless I'm wrong. Because what we like, because you could combine stuff to make things good. Didn't I do a similar problem? What did I do with that one? Oh, it's square root decomposition was the one. I think that was the one. Maybe? Is that the one I'm thinking of? There was an XOR problem recently that I struggled with and has somewhat the same idea, but I forget what it was. And I am it's been a while. That's what, in case you're wondering what I'm doing, just trying to figure out how to do the question ID. Is it this one? Yeah, okay, so there is, okay, so that's not it. I don't, because I don't think this is X or square root decomp. The 32-bit, can we DP on each of the bit or something? No, because of XOR you could flip back and forth. Especially if you do a tick, no tick, then it's actually literally all the combinations, so I don't think you could do DP, at least not that way. Oh, is this that problem that I refuse to solve? The XOR basis thing? I didn't learn it last time, so I guess that's okay. What would the XOR be? Oh yeah, okay. But I don't remember how to solve it. Well, guess I didn't learn it last time. That's why. Um, okay. I mean, okay. Let me step. How much time is 34 minutes? So first principles. You have some basis. Oh yeah, then it is just okay. Yeah, and it's just the number of bits and whether there's the number or dimensions, and then whether that bit is part of the dimension, right? Something like that. So then maybe you have right, and then it's just whether okay. And it's just whether this bit is I'm trying to figure out this from principle. Okay, so if there's a bit here, then right. Well, actually, okay, if I should like it none. This is none, then we just set this to, then we break. Otherwise, we want to say, okay, then do bits of I to remove this bit and the rest, so we get the basis, right? And then if it doesn't find it, then it's find it. And then now for yeah, okay. Maybe something like that. Is that right? YOLO. Not quite sure about this one, honestly. Okay. I think I'm missing something a little bit. Okay, what is the 30 minutes? But this is like reduced row echelon, kind of. Oh. Huh, wait. Did I do it in the wrong order, maybe? Okay, so there's 25 and 607. Do I get the max or? I guess we don't always have to use every bit because this. Why don't we? Oh, because this contains stuff that's here. Okay. So we only take it if it benefits us. Can this change? Here's my print statement. YOLO? Okay. I'm not, honestly, I'm not super convinced about this one for myself. And I mean, it's probably right, but I just mean like convinced as in like I don't feel like I know it enough. I'm still like kind of black boxing it from the last time we solved it, like from a month ago or whatever it was. We had XOR basis. Like, is this unique? Like, why is it the first number that we see is the basis? I mean, or like, I see. Okay. Because if this is not the big, I mean, it doesn't have to be. It's just that if that's the case, then the next future number or the numbers that are not this would get an XOR that we would use as a basis later on. So then the combination of them would still be the max. Because this assumes that the rest of the bits is uniquely determined a dimension. Okay. But the max part is okay, so but the max part is still a little bit confusing to me, honestly. Oh no, I mean I get it. There is like some linear algebra hand wavy, I get it, quote unquote, but honestly it is still a little bit magical to me. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.